This episode is sponsored by Indeed Prime. Indeed Prime helps software developers simplify their job search and land their dream job. Candidates get immediate exposure to the best tech companies with just one simple application to Indeed Prime. Companies on Prime's exclusive platform message candidates with salary and equity up front. The average software developer gets 5 employer contacts and an average salary offer of $125,000. Indeed Prime is 100% free for candidates, no strings attached. And when you're hired, Indeed Prime gives you a $2,000 bonus to say thanks for using Prime. But if you use the SE-Radio link, you'll get a $5,000 bonus instead. So sign up at Indeed.com/SE-Radio. This is Software Engineering Radio, the podcast for professional developers, on the web at SE-Radio.net. SE-Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE-Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
So welcome, this is Eberhard Wolff. I'm sitting here on Skype with Phillip-Carter, who is the program manager for FSharp at Microsoft. So thanks a lot for finding the time, Philip. Do you want to say a few words about yourself, introduce yourself, what you're doing, and how you're related to FSharp?
Yes. Hi, thanks for having me on the show. So as you said, I'm a program manager for FSharp Microsoft. I work on the Visual FSharp language and tooling team. So we work on the compiler, we work on the tooling in Visual Studio, and we work on integration with .NET Framework, .NET Core, and basically all things .NET. Previously, I'd worked on the .NET Core team. So one of the things that I focus on now is getting FSharp to run really, really smoothly on .NET Core so that we can have official cross-platform support for FSharp on .NET.
So can you say a few words about what FSharp actually is?
So FSharp is a functional-first multi-paradigm programming language. It's kind of a lot of words, but basically it's a general-purpose programming language that you can effectively do anything you really want to with. However, we kind of put this skew on doing things in a functional way, kind of adhering to functional programming concepts, such as immutability, higher-order functions, list manipulation, data wrangling, all that kind of stuff.
Every language is somehow influenced by other languages, and there is a whole tree of history of languages, I guess. Which programming languages was FSharp influenced by?
So FSharp is influenced by a number of programming languages. I guess the most core language that it's probably influenced from would be ML, or standard ML, which is kind of this research programming language that is oriented around the Hindley-Milner type system. There have been multiple derivatives of that, such as OCaml and Haskell, and they're kind of all in this family of languages. And FSharp is another one of these derivative ML languages that's kind of a peer language with Haskell and OCaml. And so there are pieces of Haskell and OCaml that have kind of made its way into FSharp just as an influential thing. Some bits from other languages have made it in as well. And then FSharp on the other side has actually influenced a lot of what's gone on with CSharp and Visual Basic, with some of its features that it kind of pioneered relatively early on.
When you say it has been influenced by the ML and Haskell language family, is it the features or rather the syntax that it took from those languages?
It's kind of both. So the syntax is definitely the more obvious one, not necessarily from Haskell, but if you were to look at OCaml code, for example, it looks really, really similar to FSharp. In fact, they're the ones that are the most similar. In fact, they share a lot of the same keywords, and you could write code in OCaml or FSharp, and it's generally speaking not too difficult to port it to one or the other. I mean, there's some quirks with the language and things like that you must have worked out. But then there are some of the features like having a more powerful type system, having type inference in the language is something that FSharp was certainly influenced by from those other languages in addition to ML. That's kind of one of the core things of that family of languages is the type system, because it's what I'd mentioned is the Hindley-Milner type system, which is this way of inferring types from things, and it's this algorithm that was derived by these computer scientists. And I believe it was the late late 70s or the early 80s, where they effectively came up with an efficient way to understand the types of things at compile time. So you wouldn't have to explicitly annotate every single type if you wanted to use it as that particular type. And that's, I think, kind of the central thing that influenced FSharp.
Also, you said that languages like C# are influenced by FSharp. So what are some features that C# took from FSharp?
I want to be careful when I say took, because it's more of an influential thing. So with FSharp, an example is a language-level asynchronous programming, also known as async workflows in FSharp. These were introduced before language-level async made it into C#. And although they have different concepts for how asynchronous code is handled, FSharp was kind of a pioneer in that, it was, hey, can we make asynchronous programming a language construct and have syntax around that? And will people like it? And the answer was, well, yes, people liked it a lot. And so C# was able to say, okay, well, people really do like this thing. So, what's a way that we can have language level asynchronous code in a way that feels natural to C#? And that's kind of that sort of influence that we had there. Some recent things that are coming along now with C# 7, notably tuples and well, I think it's just tuples now, but then we're going to have pattern matching coming along pretty soon. And these are things that are kind of also very foundational pieces of FSharp that people love using. And so C# said, okay, well, there's a particular style of programming, oftentimes working with data, that people love these language constructs for. And so they can look at it and say, okay, well, this is how they do match expressions. This is how tuples are deconstructed. This is how tuples are returned from functions. And we're seeing that same sort of influence happening right now in things that are being actively developed with C#. And also with Visual Basics. It also has the asynchronous programming. There's a prototype for Visual Basic actually right now that I think with a preview version of Visual Studio, you can use pattern matching and things like that. So those are sort of the areas where it's been influential right now.
Does FSharp only work on the .NET platform, or can it also create native code, or are there any other platforms that are supported?
Right now, it is only .NET. When I say only .NET, that actually means a couple different things. First of all, when you talk about concrete implementations, it means the .NET framework, which is the runtime and garbage collector that have existed in .NET for a very long time. We have .NET Core, which is a cross-platform runtime and garbage collector that works on lots of different Linux distributions and Mac, and it also runs on that, although in an alpha state right now. We're working towards a 1.0 for FSharp on .NET Core. And then it also runs on Mono, which is another implementation of .NET that's entirely cross-platform. And so there's kind of these three core places that it will run. However, outside of those, there isn't really any support. And there is no support that I know of for native FSharp. We do have a .NET native compilation toolchain that we are looking to support FSharp with. However, because that's still very, very early technology, there are quite a few areas where FSharp will just simply not work on that right now. But we anticipate being able to generate native code from FSharp with the .NET native toolchain, I'd say within the next year or two.
Are you planning to do an implementation on the JVM?
No, at least certainly not that I know of.
There are quite a few languages. So you mentioned OCaml yourself, and there is Scala in the Java world, and that's quite huge. There is Haskell, and that's also gaining some traction. Why not just port one of those languages?
Yeah, that's actually a pretty good question, because those are awesome languages, right? Scala has amazing features. Like, personally, I'm a huge fan of higher kind of types in Scala and type classes in Haskell, and it would be awesome to have that work. And actually, Haskell for a time did have a .NET implementation. I just don't think it was ever really actively maintained. But I think, because I wasn't involved in the creation of the language, I can't really specifically say why not just port one of them. But to be frank, it's just really cool creating programming languages. And, you have that level of control of saying, oh, well, there are these little quirks with this one language that I just don't really like. Is there a way that we can, flip those around or, do what we think makes sense in this context? And I would imagine would be one of the motivations there.
So it's not about creating functional programming languages for the .NET platform and using the specifics of that platform. That's not the reason why FSharp was created.
Well, so we did absolutely want to have a functional programming language on the .NET platform. I just think taking an existing functional programming language, that was just not one of the reasons that was taken for, I think, well, I guess it's just really speculation at this on my end because I wasn't involved creating the language. But there are some trade-offs that are made in certain languages that may not necessarily have been appropriate for .NET, at least not at the time that FSharp was created.
So you already spoke about type inference, and actually I think that's quite a great feature. So can you say a few words about that? As far as I understand, it basically means that you don't have to declare any types anymore.
Yeah, in a way. So type inference is, well, as you said, you don't really have to declare types. The compiler is able to figure out what things are. Now, there are some limitations to that. Usually when you're attempting to use a variable that, say you have a parameter to a function and you did not annotate the type. That is an option. You can annotate types, but say you didn't, and then you used it in some way that might be ambiguous, right? The particular operation that you're performing on it might be valid for more than just one type. At that point, the compiler will say, hey, I need you to tell me specifically which one this is because, out of this vast array of functionality that could be performed on a type, there happens to be some ambiguity going on. And so that's usually where the limitations are. It's a very few and far between thing. I think you'll find if you were to write a large solution in FSharp, a lot of code, say, well over 1,000 lines of code. Very, very little of that would ever include annotated types. And so that buys you a lot of things because, well, first of all, it's less code. And less code means less bugs because there's just less stuff that could possibly go wrong. The second thing that buys you is less what I like to call cognitive overload. Reading code is always one of those things that takes a lot longer than writing it. Well, it oftentimes takes a lot longer. Like if you're reading a large file and you've never seen it before, things like type annotations everywhere just kind of get in the way of you trying to understand what the code is actually trying to do. And so this is a huge benefit there when you're looking at a code base that you may not really fully understand yet. And then another really awesome benefit that type inference has is you can write code. You say you write a function and take some parameters, you do some operations on it, and then you return a value. You may have thought in your head as you were writing it, these are operations that are happening on a very specific type. And you just chose not to annotate it because it was less stuff for you to type into the computer. But then the compiler may have actually said, but what you've done here is actually a little bit more generic. And so you can sometimes inadvertently write more generic code because the compiler says, this routine that you've written here is valid for more than just one type. And so then you can reuse that in more places. And so that code reuse thing is kind of one of those I like to call it ambient code reuse because it's just as you're writing the code, you'll notice that you can use your functions in more places than you may have thought you could have. And that's because the compiler infers the types for you. You're able to reap that benefit.
Do you have any idea why there are not a lot more languages that use this concept?
I think one of the answers is that it's really hard. The type inference algorithm that we use, it's based off of something that's very established, but it's still an exceptionally challenging thing to get right. Not just from a correctness standpoint, but from an efficiency standpoint. Because this is all at compile time, right? None of this is happening at runtime. If you don't have a good implementation, then your compile times just explode, basically. A great example of this actually is something that recently came up with Swift. So Swift is an amazing programming language that Apple has come out with that I really love using. And I encourage everybody who's a fan of programming languages to go out there and just try it out because it's really great. But they had a bug where someone was writing a unit test and he had been using type inference and he just declared a dictionary that was kind of hard-coded for a unit test so that he could compare it with the result of whatever he was testing. And it took 12 hours to compile because it happened to go down a path where the Swift compiler just ended up in like this really, really inefficient pathway of trying to infer what type this hard-coded dictionary actually was. And so things like that are really, really challenging. And I just think it's less common because it's such a difficult problem to tackle that many languages just choose not to tackle it. At least that's my perception.
I found it interesting that you said that it's easier to read code that uses type inference, because actually I would think that if you annotate a parameter or a variable with some type, it's actually sort of a documentation, because what you're saying is this should really be this type. So what do you think about that? Do you think that's a valid argument, or would you say that, generally speaking, type interference is actually superior in that regard also?
I definitely view it on a spectrum sort of thing. I think that in the large, when you have a big file or, lots of files and just tons of things going on there, if every single thing has an annotated type, it's my belief and my sort of experience with that sort of stuff is a lot of that just kind of ends up being noise, right? If I were to call some library function that got a string from an HTTP GET, then I would know that it's a string, because that's just what the data is. And so the fact that the result is annotated with the type string isn't necessarily going to be relevant information for me if I just want to find out what's going on there. However, sometimes it definitely is a good way to sort of document exactly what this thing should be doing. And so I just kind of view it as a case-by-case basis, where if it makes sense, if you think that, hey, if someone's reading this code and they may not necessarily understand that this variable is supposed to be a string, then annotating it with a string makes perfect sense to me. Or, if you're declaring a class in FSharp, for example, and in the constructor you're taking in, say, like something called IP address and port. IP address, a lot of people might use that as a string representation, but if the particular API that you were using to register the IP address didn't take it as a string, it took it as, something else, then annotating it as that something else is definitely helpful, because it's not really a kind of a common way that people might represent that. And so I think I might even say that for common cases where you bind results to values, or you have parameters as functions or that sort of stuff, and if it's a very common way that you would represent something, then type inference and not needing to annotate types is a benefit. But if it's something where it's not necessarily the most obvious thing, then type annotation is entirely possible for you to do. And so you could go ahead and annotate it, and then it's very obvious what needs to happen. And so there's also a bit of an analog here. In FSharp, there's also something called type declaration. There are these files that usually sit alongside your source files. So say you have your source.fs, which contains your code for doing something. You could also create a file called source.fsi, which is where all of your type declarations go. So you could say, okay, well, I have this module called foo, and inside the foo module, I have these three functions. And then these three functions, all I have is a type signature where I say, well, this is the name, this is the input and its type, this is another input and its type, this is the result and its type, and then you could put any kind of documentation there, and you can add labels to the types to give them names and that sort of stuff. And so that's a sort of an effective way to document code from an API level perspective, because then you can point people to the FSI file and you can say, oh, well, you don't have to be bothered to, if all you care about is consuming this particular function, then you don't have to look through the potentially big source file that contains, a whole bunch of logic in there. You might just want to know, okay, what are the input types? What are the output types? And in that case, a type declaration file like that is incredibly helpful. So FSharp kind of has, because it has, it's type inference, but you can declare types if you think that you need them or if you have to use them. There are type declaration files that you can use to make things a bit more clear. There are a lot of tools in your toolbox, basically. You're not opted into just one specific way of doing things. And I think that's something that sets FSharp apart from many other languages, because you can choose which tool fits what you're trying to do the most, instead of having to use one particular way. That having to use one particular way thing is something that is more common with most other languages.
Do you have any idea how often those three ways, like either type interference or declaring types inline or having these separated files, how often those three features are used of the language?
So I would say that having no type declarations is the most common thing. most F-sharp code will not have it, mainly because it doesn't really need it. And usually, I mean, if it's good F-sharp code, usually it's very obvious what's happening. And so then it's not really needed. But in the cases where you need to disambiguate, or the cases where what you're doing may not necessarily be obvious, that's maybe 1% of the time, maybe 2% of the time, kind of depending on what's going on, then you'll have those sort of inline type declarations, or annotating those types in line. And then the type declaration files, those are very common for API developers. So like with the fsharp.core, which are the core libraries that we have that have a whole bunch of functions on various types, some extra types declared. That's where all of our asynchronous programming is defined and all that kind of stuff. For every single file, we also have a corresponding declaration file that has all the declared types for. And that's actually where we put our API documentation, because in Visual Studio, if you hit, say, F12 and then you go to definition, it actually takes you to that file, and then you can see, hey, this is the API code comments that we have in there, and then underneath those code comments, you can see the type that the compiler looks at when you're trying to use this particular function.
We already spoke about async blocks and asynchronous programming and how that actually influenced C#. So that seems to be another very important feature of F#. Can you say a few words about that, how that concept works?
Asynchronous programming with F# is kind of born out of a number of problems. First of all, asynchronous programming is a difficult thing, right? The context in which something is executing can be different than the context in which your normal code might be executing. And sort of reasoning about that and kind of thinking about what's going on in this context versus that context, how do I communicate? How do I take multiple asynchronous contexts and have them talk to one another reliably? That's a very difficult problem to solve. And traditionally, the ways that you would try to solve that would be with callbacks. And, there's the infamous saying in Node.js with callback hell, where you have this triangle of doom of just all these nested functions. And, it's not really clear what's going to be executed and when. That's sort of a problem that's been around for quite a long time. And so F# is not the first language to have language level asynchronous programming into it with these async blocks, but it is one of the first ones to, in my opinion, adopt it in a way that's very easy to understand. So the way that it does it is it utilizes what are known as computation expressions in F#, which are sort of these ways of being able to deal with types and what we call elevated types. So an elevated type might be an option of T, or, if you're familiar with the C# and Visual Basic world, the representation of a background task is a task of T. And then, the T inside of that is the thing that you care about. But, the stuff that's going on asynchronously, you have a handle to that with this task. Well, that is an elevated type compared to the T. And you need some way to, sort of package that up into that task. You need to unpack it when it's appropriate. And, that can also be a challenge. And so computation expressions are this general approach to being able to do that. And so we've taken that general approach and then honed in on a very specific way. So we say, okay, how can we represent stuff that is happening in an asynchronous context as an elevated type? And then how can we use this computation expression syntax to make it really easy to work with? And so they're known as async blocks, where you have a function. In this case, you would say, let my function async is equal to, and then you use this keyword called async, and then there's these brackets inside of it. And then inside of that, there's a few special keywords. So the way that you would bind the result of something to a name in normal F# is, you say let x equal to, whatever the result is. But in this case, if you say let and then exclamation mark x is equal to the result, then that's a way of saying, oh, well, in the context of this asynchronous block, assign the result of whatever asynchronous thing is happening to x, but only after it's actually finished. You can utilize that to sort of just call this asynchronous stuff inside of an async block really easily. And then the thing that you get when you call an async function that uses an async block is what's known as an async of T. And that's actually a specification of work to be done asynchronously instead of work that's already happening asynchronously. A way that I like to reason about it is say I needed you to go do something for me. In a traditional world, I might tell you immediately what you need to do, and then you go off and do it. And then you just come back and you give me whatever I need, and then I'm happy. In the F-Sharp way of doing this things, instead of me immediately telling you what you need to go do, I would then write down a specification of what you need to do. And that specification might involve multiple different things that you need to go. Maybe you need to go to this store and then this store, do something with the things that you got from the store, all that kind of stuff. And I would write that down as a specification and then explicitly hand you the specification to perform that work, rather than telling you directly each thing that you have to do. And that's sort of the model that we have for async blocks, where we can say, when you call an asynchronous function that is defined by an async block, you get a specification of the work that happens in the background. And then you can choose to start that work in a way that is most appropriate for you. Do you start it on the main thread and then await its result? Do you start it, do you queue it up to run on the thread pool and then go do something else? Do you turn it into a different type, like a task of T, and then pass it into some C# code or some VB code? There's a lot of flexibility there, where once you have that asynchronous workflow that you've defined there, you can then do with it what you will. And so those are kind of the pieces of what async blocks are in F#.
Is that something that is specific to F#, or are there other languages that do similar things?
See, I never actually used it in Haskell, but Haskell does have language-level async with some of their monadic do notation, and it might also kind of do the same thing. So there's kind of two models here, where there's the hot task model or the cold task model, where the hot task model is that by invoking an asynchronous function, there's a side effect where something is started in the background. And then the cold task is saying invoking it gives you a state machine, and then that state machine, you can do with it what you will to then start that background task. I actually don't know what model they use, but I wouldn't be surprised if it was fairly similar to what we have.
These async blocks, is that something that you can use in any other .NET language, or is it specific to F# only?
So in this case, it is specific to F#. You cannot use async blocks in any other .NET language. And the model of asynchronous programming in C# and Visual Basic, where they do have async keywords for methods, it is a different model. So I'd mentioned the hot task versus cold task model, where in F#, invoking the function doesn't start that background task. You have to actually explicitly start it. In C# and Visual Basic, invoking the method has a side effect of also starting the background task. And so the two types, task of T in the C# and Visual Basic world and async of T in the F# world, aren't completely compatible with one another. So there are some utility functions in F# in our core libraries where you can convert an async of T into a task of T, and you can convert a task of T into an async of T. But because they are these different models, you do need to have those conversion functions in F#.
Okay, I see. So there is some compatibility layer there so that you can actually use the ideas in the other languages too. Another feature that I found interesting is that F# has support for unit of measures like meters and kilometers and grams and stuff like that. What was the reason for introducing that, and how is it useful?
So units of measure, these are one of my personal favorite features of F#. So there's kind of this problem with integers and floats and doubles and that sort of thing, where the numeric value itself kind of has a contextual meaning. The number 12 might be a meaningful number in some contexts, or it just might be the number 12 and a totally useless thing. But most programming languages, they will usually have some kind of API in some language that you have to use, where like an integer is a value that you have to pass in, or a float is a value that you have to pass in. And oftentimes it's not really clear what the valid range is. Maybe it throws an exception if it's not in a particular range, or, say I was writing an API that took in the latitude and longitude, and you passed in a latitude and longitude value that were not valid for the planet Earth. Well, the function would probably fail in that case. But there may not have been a way for you to necessarily know that as a consumer of that API. Passing in 5,000 as the latitude for a point in Earth is totally valid as far as the compiler is concerned, because it's an integer. Or say you're doing something that's time sensitive, and so seconds are measured from 0 to 60, or 0 to 59. If you passed in a value that was higher than 59, or a value that was lower than 0, in most languages, that's perfectly acceptable. But in FSharp, you can have a bit more control over that, because you can say, oh, well, this integer right here is a minute. And so when you say this is a minute, then if you just tried to pass in the value 12 to a function, it would fail, because it would say, you passed in an integer, but I don't know what that integer actually was. That integer could be anything at all. You need to actually tell me, is this a minute? Is this a second? Or something like that. And it's a way that, at compile time, you can say, oh, well, this value is context sensitive, and I'm going to apply the proper context as I consume the API, which uses these numeric values as inputs. And that's a powerful thing, because you could have a function, say, add minutes, that takes in the current time in minutes and then some minutes to add. And then in FSharp, you could declare those types inline or with a type declaration file as a unit of measure for minute that you may have defined somewhere else. And so then consumers of that would have to pass in explicit integers that are minutes. If they were to pass in just regular integers or integers that were seconds or anything other than minutes, then the compiler would come back and say, you didn't pass the correct thing there. And that's incredibly helpful for any kind of things where you have numeric information that is more than just a number, like it actually has meaning.
And can you also define that you may only pass in an integer of a certain range, as you said with the longitude?
There isn't really support for this general purpose kind of thing for, defining, say, in this case, a function which determines whether an input of a particular type is valid and embedding that into the unit of measure. That itself is not possible. But what is possible is eliminating you from just passing in a number, period. Your number needs to be a specific type of number. And so that's something that's helpful, because if the number itself is of type minute, then you as the programmer can say, oh, well, because this is a minute, it probably does have to fall into a particular range.
Also, FSharp has some features around DSLs, domain-specific languages. So how does that work? How would you create a DSL in FSharp?
So DSLs in FSharp, it's a very common way to use FSharp. There's not really, this language level specific for DSLs kind of feature in FSharp. However, there are some really useful things for writing a DSL that are usually related to the type system. Well, I guess I should back up for a minute. It's not necessarily that a DSL is some sort of feature of FSharp that you can have. It's really that how you define a DSL is how you define your parser. And so FSharp has strengths for parsing things that will be very beneficial for creating a DSL. I think that's kind of the core problem is when you say, I want to create a DSL for my language. What you're actually really saying is, I want to define a parser for some input. And that parser needs to be capable of handling all forms of that input. It needs to be able to handle it in a very correct way. And so there are a number of sort of tools in your toolkit there. Your first one would be, I would say, fp-parsec, which is a third-party library, which is very similar to the parsec library in Haskell, which has a lot of built-in types that are beneficial for really, really common components of a DSL that you might use. It's got some built-in parsing techniques, so you could just pass in a type declaration and a string, and it's able to validate it based on that. But then outside of third-party libraries, the type system itself for FSharp is capable of doing a lot of things. So, for example, active patterns is a feature of FSharp, which allows you to expand pattern matching in FSharp, kind of as a backtake for pattern matching. If people are not familiar with pattern matching, you could imagine a superpowered switch statement where you can say, oh, well, here's an input that's of this type. And then in all these different cases where it could be this type, or it could be this other type, or, it could have this, maybe it's a tuple type. And so, maybe one of them is this type and one of them is this other type, or maybe one is empty, or maybe one is not. There are all these different ways that something could be passed into something that's valid. And so pattern matching is a really nice way of having having that in the language, and FSharp has that. But then you can extend that with what are known as active patterns, which are a way of associating a pattern with some functionality. So a really basic way that you could do it is you could say, oh, well, here's a string, and we want to check the case where the string contains a particular substring. Well, then you could say, well, you could define it in an active pattern that is able to take an input string and then tell you whether or not it contains a substring. And then it creates an optional type, which then you could use in pattern matching, where it would automatically go to the case in your pattern matching expression of when it matched that particular string, or it would immediately fall through to an error case that you would have defined, and it would just short circuit down to the error case. And so this sort of built-in language support for matching a case where it works and then short circuit failure to the case where it's supposed to fail is really nice because, well, first of all, it's a powerful construct. Second of all, it's not much code, so you can define that kind of parsing logic really concisely. And it plays into the type system. And so if you're able to leverage the type system even further, then you could say, well, this function, which does this sort of advanced pattern matching sort of thing, ultimately returns this specific type. And then you can let type inference sort of generalize that out if it needs to, and you could leverage that in other places. So you wouldn't need to copy that code necessarily. And then the type system for FSharp itself, just for defining record types and discriminated unions, which are known as algebraic data types, which are these recursive types, where a type could also be composed of other types that it is also composed of. So like, say you wanted to represent a binary search tree. Binary search trees are recursive types where you either have an empty tree or you have a node, and then that node could have two subtrees. And then those subtrees themselves are defined in terms of your recursive type that you have themselves. So those two subtrees are also a case of either an empty tree or a node with two subtrees. And because the type system supports that, you can very concisely represent sometimes that more advanced type information in a way that the compiler also understands.
That sounds pretty powerful. Given all these features and how powerful FSharp is it meant to be a general purpose language, or is it something that you envision to be used in specific use cases? What is the typical FSharp programmer trying to do with the language?
So I would say it is definitely a general purpose language. Things like object orientation are fully supported in FSharp. You can create classes, interfaces, abstract classes. You can organize your code in all those different ways. You can use FSharp for building user interfaces. For example, Xamarin. You can build iOS and Android apps with Xamarin in FSharp. You can actually do it with Xamarin Forms. It's excellent for building web services, for example, because oftentimes you have some HTTP function, something that maybe sits on a controller or something like that. Well, that can conceptually be modeled as a function, really. There's an input, the input is some HTTP and the output is some HTTP. And so that's also kind of a natural fit for FSharp there. So it is general purpose. Now, should it be a language that you should do everything in? Not necessarily. And I think that the same applies to pretty much any language, including VB and C-Sharp. These are very different languages. The VB and C-Sharp tend to be imperative and object-oriented first with some functional features, where F-Sharp is functional first with some imperative and object-oriented features. It just really depends on the problem that you're trying to solve, right? If you have a system where a certain component of it just really makes sense to be imperative, then you should write imperative code in a language that is really easy for you to write it in, like Visual Basic or C#. If you have some stuff that is really just, problems that you need to solve that are functional in nature, that are, that the vast majority of it is functionality, then F# is a fantastic choice. And, when I say is functionality, that can mean basically anything. That can mean you're writing a DSL, you could write web services. Maybe you're doing some sort of mathematical thing, maybe you're not. Maybe you're just doing general text processing. Maybe it's just a rule engine for just some business programming. You have a whole bunch of different rules that define how things need to talk to one another. That's all functionality that can be written in F#. There's not really a limit there. And so there are a lot of different people that use F# for different things. So, for example, Jet.com is a competitor to Amazon. In fact, one of the primary competitors to Amazon. where they have something like 700 plus microservices written entirely in FSharp, hosted on Azure, that define all of the rules for how things work with their inventory management, with displaying stuff on the website, with displaying what pages are, dynamic price changing, instrumentation of all of that stuff, checkout. Basically every single component of the website is defined in some way as a microservice written in FSharp. There's another startup in the Silicon Valley area called Takius that does work in the energy industry. And there are a lot of things like analytical dashboards, needing to collect information from all these different devices and sort of understand that information and kind of organize it in a way that people can make sense out of. All of that is also written in FSharp. There's also financial groups in New York City that write finance code in FSharp. It's a wide variety of things that you can do. And so that's why we definitely do like to emphasize that it is a general purpose programming language that you can use for just about anything. It's just a matter of, if it makes sense for you to use it, then it's a good idea to use it.
Interesting, because my impression so far was that the rise of functional programming and that everybody's interested in is primarily due to the different way of doing parallel programming. So would you agree? Because from what you said, it just seems like it's really a broad variety of things that are implemented using FSharp. So it's not specific to just, parallel algorithms or things like that.
I think things like parallel programming and asynchrony and all that kind of stuff, there are some problems there that functional programming in general is very, very good at solving. And I think especially with the rise of cloud computing and a tendency to break up monolithic services into microservices and be more concurrent, have things that are distributed across different machines, perhaps even different clusters of machines, you basically end up in a scenario where correctness is what matters. Because when you have information traveling, say, from one machine to another, how fast something could be implemented on a particular CPU. If these values in this array are loaded in this particular cache line, in this particular cache level, and hit this register at this time, that low-level stuff right there, although it's really important, becomes less of a priority when you're building something like, say, an insurance marketplace. Because that insurance marketplace, you're going to have to collect all kinds of information from all over the world and save it in all these different places and have all these different backup strategies and things like that. And so when you're dealing with information coming in and going into various places at different times, and it's not this synchronous thing, it might be happening in parallel, it might be just concurrent in general, then you care about things like immutability by default and that things don't change on you when you don't expect them to change. And you care about functionality where there's no side effects. It's just input and output and organizing things that way. And I think people are more interested in functional programming in general because of that, because their problems have effectively risen to that level where functional programming makes a lot of sense for them. And so FSharp is a way that you can do that on .NET. And there's amazing tooling that you can use for that as well. Like you can use Visual Studio, and you have a great IDE to kind of support you in solving those problems with FSharp. And so I think there's a bit of an impact that functional programming in general is having on the industry right now, and I see it on the rise, and I think a lot of people do as well, where interest is a lot higher. People are starting to rewrite things to be more functional because that's just kind of where problems in general seem to be going.
Let's talk about a completely different subject for a minute. Who's actually developing FSharp? Is it just Microsoft, or what kind of organization is behind that language?
So FSharp it's in an interesting place. So FSharp itself, the concept FSharp, is not Microsoft owned. It's an FSharp organization that effectively, I guess you could say, owns FSharp. Now, Microsoft owns an implementation of FSharp that we call Visual FSharp. And this is the language and compiler and tooling that lives in Visual Studio and that we have with Microsoft tooling. And so although FSharp kind of came out of Microsoft, it is a free and open source language that is very actively developed on by open source contributors. In fact, just to list off some recent things that have happened, one of the community members, Stefan Forkman, he's been working very heavily on changing error messages and making them a lot better. We had another community member, Will, I forget his last name, but he was another community member who implemented struct representation of the record type in FSharp. That's a really, really big challenging change to the language that not many people would normally do in an open source world. Like oftentimes it's usually some primary people that work on an open source, say language or tooling, and then there are some contributors, but usually it's kind of minor stuff. We have community members doing really hard stuff and doing really important stuff with the language. And they're also, in fact, even driving the design of the language. So our design process is done entirely on GitHub, entirely open source. We create an RFC and we say, hey, this is a proposal to change the language or to add a new feature or to do whatever we think is appropriate for the language. And then we open it up to the community and we say, we value your input. And sometimes those RFCs are created by community members. Sometimes they're almost entirely driven by community members. And, by the time we at Microsoft even get around to thinking about how we might implement something, a community member has already made a pull request with their implementation. And then we can say, oh, awesome. Well, now we can review this and, talk about it for a few months and work it out, kind of work on the little details. But it's a really, really fantastic way that it's all sort of organized. And so there's an FSharp software foundation that's, they have a board of trustees. They kind of drive the organization itself. They organize things like talks. They help with visibility and outreach of the language. And then Microsoft does some of that itself. And then Microsoft, we work very heavily on the language itself, but we also spend significant time on the tooling and making sure that the language runs smoothly on all of the changes to the .NET platform that we create as well. So that as the .NET platform evolves, the FSharp language can also kind of evolve on top of it and never get left behind. And there's kind of that sort of working relationship that we have going on.
Yeah, sounds really great. And I guess it's just another example of how Microsoft is using the open source model these days. So you said that there is an open source compiler. How is that different from what is included in Visual Studio and the Visual FSharp that you were talking about?
The current model in which ways are developed is, so there are two compilers, as you said, there's the open source one and the Visual FSharp compiler. All current development today happens in the open source Visual FSharp compiler, and then changes that are made there are typically backported into the open version. And so the open version is maintained for a few different reasons, mainly because basically if there are any different priorities that the community might have or that the organization might have from Microsoft, and they say, 99% of what you're doing is great, but this one little thing, we think we want to do it this way. They're enabled to do that with the open source version of the compiler. And although there's not really much of a difference between the Open FSharp and Visual FSharp, actually really the only differences these days are that Visual FSharp has a little bit more features in it at a point in time because just active development is happening there. But it enables the community, it empowers them to have an open version of the language that they can work with and organize around. And that's sort of how we have the open compiler and the Visual FSharp compiler. And so it's a bit interesting to call it the open compiler because they are both open and they are both open source. That wasn't necessarily true in the past when Visual FSharp was closed source, but Visual FSharp was actually one of the first things that Microsoft began open sourcing and doing open source work for. Because there was already this open edition of everything, it was really easy to just say, oh, well, it works over there, so we'll just do it here. And, kind of in typical FSharp fashion, we pioneered in a way, and a lot of that is sort of following suit. And now, almost all major activity in the .NET ecosystem is happening open source on GitHub, and it's open development as well. So, the model that we have where community members can make really big changes and really empowering changes, they can do that across all of .NET now. And that's just better for everybody.
So I could actually do a pull request on the Visual FSharp compiler?
Oh, absolutely. Then there's nothing stopping you from doing it. In fact, if you were to go there right now, you'll probably find, I don't remember what the number was, but there's pages of pull requests open right now, and they're all under review. Sometimes they're under review for a long time because the change is a really, really challenging one, and it requires months of feedback and that sort of stuff to get it right. But you could absolutely do it right now. We merge a couple of them every single day, and any new stuff that we do with the tooling on Microsoft side, we just create as pull requests too, and the community members go in there and engage. And sometimes they actually notice things that we did wrong, and they say, oh, well, why is it this way? And then we say, oh, yeah, well, we didn't really think of that. And it's a really cool relationship that we have there.
Yeah, that's definitely the power of open source. So what is the license for Visual FSharp? I mean, the open source license that you're using?
Apache license. It's Apache version 2.
Okay, so it's one of those liberal, free as in free beer licenses, I guess.
Oh, yes. Yeah, you can take this language off of GitHub. You can do anything you want. You could fork it. You could make your own version of FSharp that is totally different. No problem there. So long as you just attribute as required, then it's all good to go. And in fact, some people even do that. They have their own forks of FSharp where they might have a particular feature that they like and they use that. You can do effectively what you want here.
So what would be the easiest way to get started with FSharp development?
So the easiest way to get started with FSharp, you can go to fsharp.org. There's a lot of resources here. There's a little Learn tab there, and so you can learn about language FSharp, kind of various resources for learning. There's a lot of blogs, a lot of guides, various places of documentation, like there's our Microsoft Visual FSharp documentation. All of this is listed on this website here with all the different ways that you could learn it. And then there's ways that you can try it out, like the Try FSharp interactive environment in your browser. And there's, of course, Visual Studio. So if you download Visual Studio and then under additional components, you select Visual FSharp, you can get FSharp in your development environment, and then you can just start hacking on the language. There are a number of books as well, such as FSharp for C-Sharp developers, real-world functional programming using FSharp, a number of these that are available on Amazon. And all of this stuff is listed on the fsharp.org website. And so I would say if you were to go to the website, you would probably get all of the information that you would need to get going with using FSharp today.
Any other things that you want to mention? Any questions that I didn't really ask you?
I guess I would just encourage people to, especially if you've never looked at functional programming before, and you may have heard about it, maybe you haven't, and you've said, oh, well, I kind of wonder what that is. Dip your toes into functional programming a little bit. Try FSharp, try Scala, Haskell, OCaml. Try all these different languages and just, if anything, it can help you become a better programmer because it'll get you to think about things in a little different way. And I encourage people to get started with functional programming. And, if FSharp is the language that you choose to learn functional programming, then I'll be even happier.
I totally agree. I think it's really important to learn functional programming, not just because it's a hype right now, but as you said, to just become a better programmer also if you stay with imperative languages. So thanks a lot. Thanks a lot for taking the time and being on the show. And have a lot of success with FSharp.
Yeah, and thank you so much for having me. This is splendid.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To provide feedback, you can write comments on each episode on the website or write a review on iTunes. Mention or message us on Twitter at SE-Radio, or search for the Software Engineering Radio Group on LinkedIn, Google+, or Facebook. You can also email us at team@se-radio.net. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Thanks again for your support.